In number 17, this example, we're looking at the correlation. For buildings here, the height of the building is our x explanatory variable, and the correlated y is the number of stories that the building has. And we're going to be finding a regression line. And basically what that is if you were to draw a scatter plot of the data, the regression line is as close as possible. It's the closest possible line you can get to all the different points in your scatter plot. The distance between the different points in the line is as small as possible. It's sometimes called the line of best fit, and we use this line then to make predictions. We'll plug an x value into the equation of the line and then calculate a prediction for what the corresponding y value would be. What we want to start by doing is copying this data into Excel. In Excel, then select the data, go to Insert, click on the picture of a scatter plot, and get your scatter plot created. Right click on any of these points, click on Add Trend Line, or on Linear, and we want to display these two things. And you can move those values up there. So now you can see here the equation of the regression line is given. And so you have your slope and your y-intercept that you're going to want to enter in here for the answers. And then you can match up the correct scatter diagram with what you see over here in Excel. To answer the rest of these questions, what we're going to be doing is plugging in different values for x into our regression equation and calculating a predicted value then for y based off this equation. Now this equation is based off of the data we have here. So we only want to plug in x values that are within this range of data. If it's way above our highest value or way below the lowest value, the equation should not be used to make a prediction of y based on an x outside of this range. The only one that's an issue out of these four is 310. It's way below the smallest value here. So when it comes time to plug in 310, that's not a meaningful x value to plug in. So we won't use our regression equation to calculate the corresponding y value for 310. For the other three, I'm going into Excel. We have our equation here of the regression line. So for each of the different x values, just plug it in here where x is, and then solve for what y would be. And so I did that for each of these different x values, and I get the corresponding prediction for what y would be based off of these different x values. For number 18, our correlated data is from baseball. It's the number of wins a pitcher has, and then the y value, the response variable, is their earned run average. So you want to copy that into Excel. In Excel, we'll select the data, go to Insert, click on the picture of a scatter plot, make it a little smaller here so we can see it, and then right click on any one of the data points, add the trend line, and we're on Linear, click these boxes, and we get displayed here the equation, our linear regression equation, the slope and the y-intercept we're going to use for our answer. So round those values as indicated, and we'll use this regression equation to make predictions for y based on different x values. In other words, if we knew the number of wins a pitcher had, we could plug it into this equation and predict what their earned run average, their ERA, would be. Also match up the correct scatter plot to what we saw over here in Excel. Now our regression line was completely based off of the data we had, so it's only going to be useful and make good predictions for y if we use x values that are within the range of our data. So 5 is below our smallest data value by quite a bit, so we do not want to plug 5 into our regression equation to get a corresponding value of y. 10 is within the data, so we can plug 10 in. 21 is just barely larger than our largest value, so it would be okay to plug 21 in. And 15 is within the data. So for plugging in 5, it's not meaningful to predict y based off of 5. The ERA based off someone with 5 wins, because we don't have anybody with 5 wins in our data set. But for the rest of them, we're going to plug those values in. And so plugging in different values for X, the number of wins the pitcher has, we plug that in here and we can predict what Y would be, what that pitcher's ERA would be. So just plug each of these X's in and you get the prediction then. Based on the regression line, we get the prediction for what Y would be.